Hey everybody, welcome to the second tutorial on creating a game in Max. So we are still talking about Space Invaders, and let me show you the game we are talking about. The same I introduced you in the last tutorial. So it's basically the Space Invaders game, and in this tutorial we are going to see how to create the texture for the aliens, so actually the aliens themselves. We are going to see in this tutorial how to create that part, okay? Okay, so let's stop playing. And let's go on with the tutorial. So, first of all, what we need? First of all, we need to create an image with the texture for the alien. Let's create just one for the moment, and then we will see how to create multiple of them. So first of all, we need a jit noise. Okay. So a jit noise, 4 planes, float 32, and dimensions 5 by 10. Oh, by the way, this is where we left in the last tutorial. We have our tank that can move left and right. So this was simply the content of the first tutorial. Okay, so let's go on. Sorry. Let's create a bang to bang out our noise, and then let's create a matrix to make the dimensions of the noise matrix bigger, but without changing its content. So we create a float for 4 planes matrix float 32 200 by 200 adapt 0. So this will give us more resolution for that matrix that comes inside. Okay, and then let's create a jit.gen, and this is where we are going actually to create our alien texture. Let's attach a jit window to visualize the result. And we can also give a title to this jit.gen. Let's call this, for example, alien texture gen, something like that. Okay, let's go inside. Now, what we want to do is basically to mirror the matrix that we are getting inside, the noise matrix that we get inside, in order to have a more interesting noise image. So in order to do that, we actually don't need these things. The output we need. In order to do that, let's create a sample object. And let's set the bound mode to mirror, because this we are going to use to mirror the incoming matrix. Okay, so if we simply connect the input to the output, we just see a noise matrix 5 by 10, okay? And now we want to mirror this matrix in a way that we have 5 pixels on the left side of the image and 5 pixels on the other side on the right side of the image, and still 10 pixels on the height of the image. So to do that, we use the sample object. So let's create the normalized coordinates. Let's switch them. So let's switch the x, let's switch the epsilon, so we can work on them individually. Let's multiply the x by 2. So we are going to sample the x of the matrix 2 times. But when x goes above 1, then the coordinates will be mirrored. So we actually will mirror, will get the matrix, the pixels, the cells of the matrix, but going backward. So first we go forward, and then we go backward when we mirror. Let's see how this looks like. So let's do something. Let's attach these guys. Okay. So this is our matrix now. We have the 5 cells are being mirrored on the x-axis, and the vertical axis still remain the same. So okay, this is not our alien yet. Let's see what I have to do to make it more alien-like. Well, let's just switch one value from this one plane, the first plane from the noise matrix, and let's say when it's greater than 0.5, give us a 1, and when it's smaller, give us a 0. And there it is. Now it looks a bit more like an alien, eh? This could be an alien from Space Invaders, right? What we miss now is just the color. So we have to give a color to this alien. Now, if we just use the color from the noise matrix, we could also do something like that. And then our alien will be colored with multiple colors. But actually, I want that the aliens are just one color for each alien. So what we can do is again to sample the incoming matrix, sample the noise matrix, but using just one cell from this matrix. So for example, the cell in the center of the matrix. Then what we can do, for example, is to multiply this result with this result. Actually, we don't want that the alpha of the texture is below 1. We just want the alpha always to be 1. So let's actually set the alpha to be always 1, and then let's switch the single components of the noise matrix, the single color components. Let me put this a bit more here. So red, green, blue, and then let's attach them here. The alpha is in the first channel, since we are working with matrices now. We are working with images. The alpha is always in the first plane, the first channel of the vector, the first component. And okay, we have our colorful alien. That's it. That is basically it. One thing that we could do, sometimes the alien is a bit dark, the color. So what we could do is to normalize actually the color of this color from the noise matrix, in order to have always a magnitude of 1, doesn't matter. It will just rescale all the values in the color to always have a magnitude of 1, a length of 1. And this gives us a slightly brighter result. I think. I'm not really... This maybe doesn't do anything useful actually. But yeah, let's just keep it because it also doesn't harm. Okay. Good. This, for example, is quite dark. Yeah, so this actually doesn't prove anything. Yeah, we can also actually not use the normalized. This is really not... I think it's actually not useful. Okay, let's do it like that. Yeah, this is actually okay. Okay, now let's see. Now we just have one texture. Now, as I did in my version of the game, so let's take a look at it again. There is some sound that I don't want. So I'm actually accessing all the aliens textures from a single big texture. So I've placed all the textures of the aliens in a single big texture in order to have them stored all in the same place. And this also saves us a bit of computing. So somehow is the most elegant and efficient way of storing the alien texture, in my opinion. Maybe it's not, but this is what I thought. So let's store a number of those matrices inside a big texture. Let's say we want to store 16 of them. So this will give us 16 different textures for the aliens. We will have more aliens than 16, but they will use a texture, randomly chosen texture between the 16 that we are going to store. So in order to store those textures, we have to create a small algorithm. But first of all, we need a texture where to store the matrices. So let's create it. jit.gl.texture, game tut. And let's give this texture some dimensions. So since we want to store 16 of these alien images, we create a texture 800 by 800. So this will basically have 4 textures on the x-axis and 4 matrices on the x-axis and 4 images on the y-axis. Okay, then let's give to this texture the adapt 0 attribute just to be sure. And then let's give it the filter none, so it will apply no interpolation to our incoming matrices. Now, let's actually attach this here. So if we do something like that, basically our incoming matrix is going to fill the whole texture. But this is not what we want. We want to store 16 of these matrices inside this texture. So in order to do that, we can use the message jit subtext matrix. Sorry, it's not jit, it's just subtext matrix. So this message followed by the name of the matrix will set the incoming matrix as a sub texture inside the big texture. So in order to send directly this message followed by the name of the matrix, we can use the substitute object. And we can substitute the word jit matrix with the word subtext matrix. So if we connect this here, instead of getting jit matrix, subtext, not dubtext, we get the word subtext matrix followed by the address of the matrix. Okay, so if we connect this to the jit.gl texture, it basically it doesn't know where to put this subtexture, because in order to work with the subtexture message, we have also to provide some dimension start and destination, some destination dimension starts and some destination dimension end. So we need also to give to the texture the attribute use dim1. This will allow us to work with the message dim start. So 0, 0 will be the the left top corner, and dim end will be the end, the other corner of our matrix. So somewhere like here. Okay, so if we give first the message and then we bang, we should see our matrix. We don't see, maybe let's bang also the texture. Yes. So now our matrix has filled one portion of this texture. So as you can see, it covers exactly 4 squares in the texture. This is kind of the default image of the texture. Covers these 4 squares. So it takes exactly 1/16 of this texture space. Okay, now we have to come up with an algorithm that basically will do this automatically every time we request some new textures for the aliens. So let's think about it. What we want to do is basically to fill first the x dimension and then we want to go one step further on the epsilon dimension and then fill the x dimension, then go one step further, fill the row below, and then fill the row below. So first we fill all the columns, and then we go to the row below and we fill all the other columns. So let's see how we can do that. Let's, for example, use a counter. Let's use a counter that will go, it will go from 0. So it will count going from 0 up, and it will count from 0 to 15. 0 to 15 is basically 16 numbers, so this will use as the index for our texture. Then what we have to do is to create also a modulo operator. So this modulo operator will just give us numbers between 0 and 3, right? So 1, 2, 3. So we bang here 4 times and we receive numbers between 0 and 3. So this number we will use as our index on the x dimension. Now what we have to do, let's start by setting these as variables like that. And then what we want to do is actually to send this number into two different places. But let's start with the x. We will use this number both for the epsilon and for the x. But let's start first with the x dimension, the x index. So what we want to do is to multiply this number by 200. So now we get 0, then we get 200, and then we get 400, and then we get 600, and that's it, okay? Because then it goes back to 0. So this will be our index on the x dimension. So 0, 200, 400, 600, okay? So this will be the x of our dim start. Let's create a pack object, pack, not poc, because we want to be able to decide when this list gets triggered. So let's then create another trigger object. So this we will trigger the list out, the left number. This will be our x position of the matrix inside the big tester. And this will be this dimension end on the x axis. Okay, so we basically say, okay, 200 pixel farther on the right, then you set this will be our this dimension and for the x. Okay, it's quite tricky, but let's see if we can get this right. So if we click, let's see the order in which we have to click. Let's create another bang. Let's create a trigger object, bang bang. So first we have to click here, and then we have to bang that. Let's see. So if we bang, oh, there's a problem, as you can see. So basically, yeah, because this dimension end is also set to 0. So okay, before we actually test it, let's finish the algorithm. Doesn't make sense otherwise. So let's go on by calculating the epsilon for these coordinates. So let's create another counter. This counter we go from 0 to 3, and this will be our epsilon. This will be our epsilon coordinate. So this number here we have to see when it's equal to 0. So when it's equal to 0, count another time. So when it's equal to 0, this will send a bang to this counter object here. Let's move this a bit to the left. Okay, so the first time this number, let's set actually this counter back to 0 on next clock. Also immediately. Okay. So when this will be equal to 0, this will send a bang to this counter that will output the number 0. Okay, let's actually place a couple of number objects just to monitor what's going on here. So when we bang here, this will go to 0, please. So when we bang, this will go to 0, and since this is 0, this will no, but this is not the right way. I have to attach this 0 here on the next clock, otherwise it starts with 1. So we send that 0 to both these counters, then we bang here, then we have 0 on both of them. Okay, so this will be 0. Then we have to use this 0 on 2 places. We have to use this 0 as our destination dimension start, but first we have to multiply this by 200 because our matrix is 200 by 200. And this will be our epsilon position for the dist dimension start. And then this will be our epsilon position for the dist dimension end. So this should be now okay. So let's try. Let's actually do like that. So what are we getting out of this actually? Let's take a look. Ah yeah. Okay. Ah yeah, of course, we cannot simply multiply this by 200, otherwise this would be 0. We have first to add 1. So also when this is 0, this will actually start from 1. This will actually start from 1. This is this dimension end for the epsilon. So this will actually start from 1 and go down to 200 on the epsilon axis. Okay, so bam. Let's start from 0 again. Bam. And this is the first. Bam. And there's a second. And now it seems to work. Ooh. We have a problem with the last one. Let's see. Yes, we have a problem with the last matrix. This dimension 800 by 400. I think that's because actually we don't have to multiply by 200 because actually our index starts from 0. So what we have to do is probably to subtract 1 from that. So let's see if I'm right. Can just add 199 to that. To that we have to subtract 1. Because actually our index starts from 0, so we don't want to have 200 as the last number, and we don't want to, yeah. So let's see if this works. Pam, pam. Let's do a bit of them, then see if it works. No, we still got, oh yeah, yeah. That works now. Okay. So, but let's see, why didn't he delete the old matrices. Oh, okay. Sorry. So, sorry, let's start from scratch. 1, 2, 3, 4. 1, 2, 3, 4. So we should have filled the first 2 rows. Okay. 1, 2. So this is this. Somehow it doesn't fill as I expected. Come on. Pam. Okay. Let's actually create a metro that does this automatically. So let's say metro 300 active, and let's say you send a bang first to the algorithm and then you send a bang out to the texture so we can see the result. Okay, so it's automatically filling the texture. Okay, and it seems that it works. Yes, it seems that it works. As we can delete. Okay, so this was quite tricky, but we did it. Let's actually stop this metro here. Okay, let's actually put all of these inside the sub patch. So all the stuff we did in this new tutorial, we put it here, and we call these texture or alien texture. Aliens texture actually. So still working. Let's actually clean this up a bit. Okay, what we have to do now is simply to choose how we want these textures to be filled. So as in my game, I did it like that. When we press the space key, so the space key on the keyboard, then it will fill all the texture and then it will stop. So let's see. Let's create a key on our main patch, key object. And then let's say cell32, this is the space key on the keyboard. And then let's say send space bar bang. Let's receive it inside here. So let's actually delete this active from here. Let's receive the space bar bang. And let's trigger actually a 1 with that. So we can say okay, when this bang is received, send a bang to this metro object. Send also a 0 to this guy. So let's do it actually like this. Send a bang and a bang here. Send a 1 to that. So I actually don't need this 1 here. Send a 1 to this guy, but first send a bang to this 0 message. So we set a 0 for both these counters. We initialize them. So then we have to find a way to stop this metro when this is over. So we can use the counter. We can use the bang from the counter. It will send a 1 out from this outlet when it arrives to 15. So we can use that to actually send a 0 to the metro object. All right, let's see. Suck. So let's see if this works. I press the space bar, and it's filling the matrix, and it stops. Great. Let's see a bit bigger view, so I press the space bar, the texture gets filled, and then it stops. Okay, good. So we created the textures for our aliens. Good. In the next tutorial we will see how to apply those textures to the aliens and how to animate them. Oh, sorry, I've just seen that there is a problem with this algorithm that we made, that I made, because basically when we are starting from 0 and we subtract 1 to 0, then we set the dimension start x index to be -1, and this is not what we want. We want that the minimum is anyway 0. And the same thing happens for this dimension, destination dimension, and the epsilon. So we don't want to go to -1, but we always want to be at 0. So what we can do is to use the maximum object with an argument of 0, so it will always take the maximum number between 0 and the number that comes inside. Somehow this looks like a not so elegant solution, so I will leave you as an exercise to you to find out which is a more elegant solution. For the moment, that's how I will do it. So if I press the key space bar, it will work. It was working also before, but this is somehow conceptually correct. Before was wrong. Okay, thank you for following. I hope this was clear enough. And I encourage you to take a look at my website, which contains a lot more tutorials, or my YouTube channel directly. And if you want, you can also support me on Patreon, where you can download a lot of jitter patches, so patches about visuals in Max. Okay, thank you and see you in the next tutorial. Ciao guys.